All right, I'm gonna go over the bottom-up dynamic programming solution to this problem. And if you haven't seen my last video, I go over the top-down solution, and I go over the recurrence relation in a pretty decent amount of depth. So I feel like you should go watch that video first as like a prereq to this video. But anyway, in case you haven't, I'll go over it anyway. So let's say I ask you, what is the longest increasing subsequence starting from n minus 1? So this is the last index in this nums array. Well, the longest increasing subsequence of the last element is just going to be, if we start from the last element, it's just going to be size 1. And if I ask you, okay, now what's the longest increasing subsequence if we were to start from, say, n minus 2? So this would be some index. This would be the second to last index in this nums array. Well, this is going to be equal to 1, because we're starting from this index. So we're going to take one element. It has to be at least one element big, right? The longest increasing subsequence. 1 plus LIS of n minus 1, but only if the number at n minus 2 is less than the number at n minus 1. So we're going to say 1 plus ls n minus 1, where nums at n minus 2 is less than nums at n minus 1. And that makes sense, right? Because this has to be an increasing subsequence. So we're just checking if the value at this index is greater than this, then we can go ahead and do 1 plus 1 here. So which would mean that the longest increasing subsequence here would be 2. And if this was smaller, like let's say this was the value, or let's say the value here is actually smaller than this value, or smaller or equal, well then the longest increasing subsequence would just be 1 here for for the longest, for LIS of n minus 2. Okay, but anyway, let's say I ask you, now what is the longest increasing subsequence of n minus 3? Well, this is just going to be 1, because we're just starting from this index. So it's 1 plus the maximum of LIS n minus 2 and LIS of n minus 1. Where, so if you think of this, this n minus 2 and n minus 1, think of it as like an index I. So we're going to say where nums at n minus 3, so I'm just getting that n minus 3 here. So this number at this, so the number at this index has to be less than the number at index I. So again, this index I would be these indexes here. So we just take the maximum of the previous two longest increasing subsequences, so long as the number that we're currently at is smaller than the number starting at those positions. And if we just kept going, this would just, we could actually just copy paste this. And L of n minus 4 would equal 1 plus LIS of n minus 3. And then we do LIS n minus 2 and minus 1. We're just taking the maximum so long, and then we're only going to take we're taking the maximum of the ones that satisfy our condition, which in this case would be n minus 4. So as long as this number here, the number at this index is smaller than the numbers at these indexes, then just go ahead and take the maximum of those lengths and then add 1 to that. All right, so I think that explains the recurrence relation. So let's just code this out. So let me just delete some of the spacing here, comment it out, comment that out, and let's create our DP array. So I'm just going to call it LIS. So LIS equals new int of the length of the nums array. And so notice this, we have to initialize n minus 1 to 1, and these actually all are going to start out with at least 1. So I'm just going to fill up the whole thing with 1s. So LIS of 1, and this just makes the code a little bit nicer later on. But anyway, so we're going to do for int, so we need to loop from n minus 2 all the way to index 0. So we're looping from the second last element to the beginning of the array. So for int I equals, and you know what, we're gonna put this in an array. So int n, or we're gonna put this in a variable. So int n equals nums.length. And I'm just doing this so that this can look nice. So I equals n minus 2. So we're just starting at n minus 2. And we're gonna go all the way to the beginning of the array. So I greater or equal to 0. And let's subtract that. And now, so if we're at n minus, say we're at n minus 4, right? Now we have to loop from n minus 3 to the end of the array. So for int j equals I plus 1. So if we are n minus 4, so if this was n minus 4, this will give us n minus 3. And j is less than the end of the array. Plus j. Okay. And now we need to check our condition here. So we need to make sure that the number at I is less than the number at j. And if it is, then we can consider adding this length to our increasing subsequence. So we're going to take the maximum. So math.max of lis of I, or 1 plus lis of j. Okay, so we're just looping through all of our previous computed longest increasing subsequences, and we're just taking the maximum of it, so long as like this condition is satisfied, right? We only check if that condition is satisfied, and then we add 1 here. Cool. And now that should actually, let's just get rid of this. Oh, and we need to do lis of I equals the maximum. Okay, cool. So yeah, so now this is should be good. And now we need to, once we've computed the longest increasing subsequences starting from every index, now we can just loop through our lis array and look for the biggest number that got stored. So we're gonna do, let's do int longest equals 0, and loop through lis.length plus I, and if lis at I is greater than longest, then set longest equal to lis by. Okay, and then just return longest. All right, cool. So let's just run this and submit it. All right, cool. If the video helped at all, you can give it a thumbs up. You can subscribe if you want. Cool, bye.